That's what I want. Oh, snap. Let's do this.
Easy, how are you?
Living the dream. If my life got any better, they'd make a movie. All right. So, fractions today. Fractions. How are you? Okay. Fractions today. How, from yesterday, or really from when you were in elementary school, right? How do we add and subtract fractions?
Wait, no.
Well, that's what we did yesterday.
Yeah.
Yesterday was greatest common denominator. Okay. Right. So just the common denominator, right? Okay. Whoop. Tap the brakes. Got to do this. Gotta adjust my. Did you want me to record "Stay in Your Lane," bro? Okay. Right. So what is our common denominator? I don't. What is it? That's my question. What is it? But what is it? So, and love it. I'm going to go over here. Oh. Okay. What's missing from the top of the first one? 1 minus sine of x. What's missing from the top of the second one? 1 plus sine of x. Okay. Can't. Because if we simplify, we're stuck back and we're back to here then, right? Oh man. So now what do we do? Add the tops. Yep. Okay. So we get 1 minus sine of x plus 1 plus sine of x all over 1 plus sine of x, 1 minus sine of x. Love it so far. Now what? On top? Okay, and so what's left over on the top? 2. What about the bottom? Well, let's take a pause for the cause here, and let's talk a little bit about some algebra. Okay. Back in the day, what can you tell me about those two? What can you tell me about those two? And no, x is not equal to and x does not equal negative 2 because there's no equal sign in this problem. So what can you tell me about those? There's a special term in math for those two terms. Because if I were to multiply them, I get that. Remember what it is? Not a perfect square. That's if we were going to the left, we would say it was the difference of perfect squares. But we have a special term for these two terms when they are together. not factors. That's if we're working to the left. Okay? Try a different one. What about if I had this? 1 plus the square root of 2 and 1 minus the square root of 2, and I multiplied those two together. I'd get 1 minus the square root of 2 plus the square root of 2 minus the square root of 4, which is 2. And so this is really just negative 1. Or maybe you remember it from when we were doing 3 plus I and 3 minus I. We get 9 minus 3I plus 3I minus negative 1, or negative I squared, which is minus negative 1. So this just becomes 10. Starts with a C. Nope, it's a single word. Starts with a C.
What's the second
One of the 26 letters in the alphabet.
What's the last letter?
One of the 26 letters in the alphabet.
Yeah, this was the first one.
I did tell you the first.
How many letters?
Many. Say it loud. Conjugates! They're conjugates! Okay, so let's go back. Sorry, buddy. Sorry, buddy. What about, and so more importantly, let me go back to the going back to. Notice in these two, in blue and purple, what happens to the radical in blue? What happens to the I in purple? It disappears, right? In algebraic terms, the linear term disappears. Okay? All right? So those are called conjugates. What can you tell me about 1 plus sign and 1 minus sign? They're conjugates, so that middle term's going to disappear. So this is going to become 1 minus sine squared of x. Now, you may be saying to yourself, what'd that do for us? Well, it actually did a lot for us. Because what's 1 minus sine squared of x? It's cosine squared of x. So this becomes 2 over cosine squared of x. Which is what? In a nice, pretty way, how can I write 2 over cosine squared of x? Nope, I can write it even prettier.
2 secant x squared.
2 secant
Squared x.
2 secant squared of x. That 1 over cosine is secant. So 1 over cosine squared would be secant squared. 1 over cosine to the 8th power would be secant to the 8th power.
How is that any prettier
Then 1 over 1 plus sine of x plus 1 over 1 minus sine of x.
No. 2 over cosine squared x.
Because it's not no fraction. And then and to quote you two from earlier in class, I don't like writing fractions because I don't know where to put the bar.
That is false. Okay, we did say that. So you're just moving the top number in front of the secant.
Because that would be like 2 times 1 over cosecant.
But if it was
Or cosine
3
squared, yeah.
over cosine squared of x, you couldn't do that.
If it was 3 over cosine squared of x, then it would be 3 secant squared, or 3 secant squared. Yeah.
Oh, but you said it was 8.
No, I said if it's 1 over cosine to the 8th power, then that's secant to the 8th power. Yeah. Okay. I would like you to now try number 14. No problem. Glad I'm here to assist. Okay. So I would write this as my common denominator is going to be tangent of x. The first one, I don't need to adjust at all because I'm already in my common denominator. The second one, I need to multiply by tangent of x, so that becomes tangent squared of x. So that becomes secant squared of x minus tangent squared of x all over tangent of x. Agree? Okay. Secant squared or tangent squared, we have number 11 to figure that one out. Secant squared is tangent squared of x plus 1, then minus tangent squared of x. I'm in a funky part of the board there. See if I can redo that here so that it's not so funky. So all that's left on top then is 1. Tangents cancel each other out. So I have 1 over tangent of x, which is cotangent of x. Okay. Cosine of x plus sine of x, tangent of x. I know. Do it on your own? Do it. All right. So how I done did this one is I would say, well, sine of x is, or sine of x tangent of x is sine of x times sine of x over cosine of x, right? So this is really sine squared of x over cosine of x. Right? Common denominator then is cosine of x. First one needs to be adjusted with an extra cosine. So on top I get cosine squared of x plus sine squared of x all over cosine of x. Cosine squared plus sine squared, 1. It's the hammer. One over cosine of x, secant of x. next week, we're going to tell you, like, so the problems for next week are, it's going to be cosine of x plus sine x tangent x equals secant of x. Prove it. And you prove it by showing it. So that's where we're going to. So right now we're working. Love it. Okay. Complementary angles. What does it mean, thinking back to when you were in geometry, what does it mean to be a complementary angle?
Two angles whose sum is 90 degrees.
So they make a corner, right? Well, complementary makes a corner. So they add up to be 90 degrees. Okay? All right? So let's look at how can I algebraically represent any complementary pair of angles. So if I have theta, right? So if I have theta, that's going to be, or what am I going to have to add to it? And that's going to get me 90 degrees, right? So how can I represent this complementary angle? If the two angles add up to be 90 degrees, and one of them is x, what's the other one? Say it loud.
90 minus x.
So in this case, it would be 90 minus theta. Okay. So my two complementary angles are theta and 90 minus theta. Okay. If this were in radians, and I still had theta as my first one, what would my second one be? And what would 90 degrees be in radians? Well, first off, let's start there. What's 90 degrees in radians? Pi over 2. So my complementary pairs would be theta and pi over 2 minus theta. You forgot the minus theta the first time. Okay. Now, let's look at comparing those two on your calculator. So somebody figure out what the sine of 20 degrees is, and somebody figure out what the cosine of 70 degrees is. Okay? Which one did you go with?
Sine of 20.
You went sine of 20? What did you go with? Cosine of 70? Okay, so I'm going to read off because I got cosine of 70 on mine. You tell me if it's exactly the same. 0.342, 0.20143.
Yeah, 0.342%.
So you must only be able to go out to 3 decimal places.
Oh no, I can go more. 0.342020143.
That's just what I said.
Oh.
Yeah, yeah. So those are the same. Okay? So these both become 0.3420, right? I think it was. Yeah. Okay. What about the next one? Sine of 42 and cosine of 48. What do you got for sine of 42?
0.6691306.
Works for cosine of 48 then? Okay. So these ones are both 0.6691. I'm going to stop it at 4, just so you know. Okay. What about sine of 68 and cosine of 72? We got cosine of 72. Who's got sine of 68?
You mean cosine of 22?
What did you do 72 for?
That's what you said. I wasn't looking up.
Why you gotta listen to the words that come out of my mouth?
There.
Okay, I'm ready. You ready, Express? Go for it.
0.9271838855.
Love it. Okay. So I'm going to round that to 0.9272. So those are both the same. Okay? Now, what that does for us then is that creates these off of your unit circle sheet. This is numbers 12 through 17. So the sine of a so we've got an angle and its complementary angle. So if we have the sine of an angle, that's the cosine of its complement. The cosine of the angle is the sine of the complement. Tangent of the angle is the cotangent of the complement. Cosecant is the secant of the complement. Secant is the cosecant, cotangent is the tangent of the complement. Okay? Right? So it switches forms. Or switches to its pair share. Okay? So for instance, what we can do is now we can have something like this, where we have the sine of negative x times the secant of pi over 2 minus x. And unlike me, that's not very pretty. Okay? Right? But let's make it be pretty. Okay? So the sine of negative x is really just what? No. Negative sine of x. That's number 2 on our unit circle sheet. Okay? Times what is the secant of pi over 2 minus x? That's the cosecant of x, right? Cosecant of x is 1 over the sine of x. So this becomes negative sine of x over sine of x, which is just what? Negative 1. Which is much, much more like me. Right, KB? Okay. Oh, snap! Let's do it. Well, by let's do it, I mean you do it. Okay. Start with this one. What does that one become? Sine of theta. Okay, then we'll go to this one. What's this one? Well, tangent is sine of theta over cosine of theta, right? Times cosine of theta means that that one is just sine of theta. Okay, now I'm going to bring this, oops, tap the brakes. I'm going to bring this one down just a little bit more. Okay, then this one is just sine of theta minus sine of theta plus sine of theta is just sine of theta. Okay? What was wrong with it?
No. It's like easy when you think of it.
It's just a matter of seeing it. See now, and this will hold for sure next week too. I always attack the ugliest thing first because there's more that you can do with the ugliness than there is with the prettiness. Okay, So I would start with, like, sine is just sine, okay? Here, I know that there's something I can do with those because I can combine them into one trig function, okay? Here, I know there's something, yeah, because that's, yeah.
Yeah,
mhm.
honestly,